Sorry, guys, I know that we started late. It took time for me to wrap up the previous class. Okay. How are we in absolute value functions? Are we good? I have a test for you. I'm going to give it to you. You can do it at your own pace. Does it make sense? Meaning, I don't want to take the class time, but I prepared a 10 or a 20 question test. I don't remember. Can I give it to you at the end of the class? Will you finish and then log off? That way we make sure you are aware of, you are very clear with what we have done. Does that sound good? But does it sound good? Yes, no. There's two different answers and I accept both.
I don't think I can do it after class because I have to go somewhere.
You have to go somewhere. Then I don't know, you'll miss the test. Who else is going to miss it? Who can take it? It is
Are
okay.
we taking it while the class is going on or after?
Oh, you don't want to take it you don't want to take it after?
Yeah, because I'm busy after this class.
Then class time will go, right? What do we do? Let me see how long is the question, how long is the test, then I'll give you within the class. Let me see, because I really want to move on as well.
Yeah, because after the class, I have something right after.
Okay, then can I give you correctly exactly 20 minutes of the class?
Yeah. How many questions is it?
20 questions. Can we try? It's a time crunch test and you're all in algebra too. Can I give it?
I'm fun.
Ananji, what do you think? Huh?
I-
How many questions is it? I didn't hear you.
20 questions, 20-minute test. Can I give it to you?
Yeah, I guess.
20 questions, 20-minute test. It's not a hard one. Really not
Auntie,
yeah, go ahead.
can you like go over like some of the stuff that like we might see on the test and then we take the test in class?
Yeah, absolutely. Given, okay, yeah, if you want me to, quickly I'll do that. I'll do that, but I want to finish and move on with the class as well. Let's see. Let's see what I can do because I want to start quadratics and keep moving. How about this? You're able to see the board, right? Good idea. How about this? What are the transformations on this absolute value function? What are the transformations on this absolute value function? Anybody?
4 to the right.
Yeah. Don't start with translation. Start.
A compression by 2. A vertical compression.
Guys, you're all going to help each other out, not leave somebody to say answers. You're all going to help each other out.
A vertical stretch by 2.
Vertical stretch by 2. Good job. Vertical stretch by 2. Then
Right 4.
Right 4.
right 4. Then
Up
4.
up 4. Good job, guys. So that's easy. And then what else? And do you know how to graph this? Easy ones. Let's say how to graph. Do you know how to graph this function?
Yeah.
Yeah.
Ananjay, are you comfortable with graphing it?
Could you go over it one more time?
I don't know.
Graphing any function, Amma. You can graph any function, right? Would you be able to graph this function?
I don't know.
Be it any function, a line function, you can graph it, right?
Oh yeah.
How will you graph the same thing? You'll graph this. Right? Put a table of xy values, put negative value, positive value, and zeros for the x, and then calculate y and graph it.
All right, thanks.
Make sense? But suppose you can't submit it, right? Then if I give you this graph, and if I give you this graph, and if I say, hey, graph both and compare. So just write the comparison as your answer. Then I will review what you have done. Make sense, guys? Okay. And would you be able to solve equations inequalities? Would you be able to solve? How about if I give you this? What do you think about this? Would you be able to solve this?
Yeah.
Yes.
How will you solve?
You make it x plus 3 equals negative 4 as 1, and then you make x plus 3 is equal to 4.
Not really, right? Can an absolute value be negative?
Oh, yeah. In that case, it's no solution.
But to deceive you, there is no solution for x because the absolute value can never be a negative number. Make sense? Okay. How about this? If I give an absolute value equation, do you know what is the vertex? How about this? X minus 4 plus 3 equal to 0. What is the vertex and intercepts? Do you know?
4, comma 3 is the
Yeah.
vertex. And then
Mm-hmm.
would be wait, 4.
Intercept means what?
So there would be no x-intercept,
Yeah,
and then
intercept means x-intercept means y value will be equal to 0. Solve this equation, that will give you the intercepts. Make sense?
yeah.
Ananjay, are you following?
Yeah.
Oh, good. If you're not following, stop, guys. Stop the class from going on. And you know this, yeah. Okay, then there are some word problems. Okay, there are some word problems, but there was one confusing problem. Okay, if you're asked to graph, you don't have to graph, but then please answer the question. Okay, answer the question, that helps me a lot. Got it? And there was one confusing question. I'll tell you the confusing question. Okay, how about this? This is the most confusing question I felt. Let me discuss that with you because I just want to go over that question. See, what is this, guys? This is a challenge question, I know, but see, this was a challenging question. What is this, guys? I don't know. Let's see. How about this? Can we try that one? Can we try that one? What is this piecewise form? First, let's find out what is this. State the breakpoints. Give the correct piecewise form. You know what is a piecewise function? How many of you know what is a piecewise function? This is just extra knowledge that I want you to know. What is a piecewise function? Let's say I have a function like this, okay? And then I have a function like this. So this is my entire function. Can you write a single equation for the entire graph? Write a single equation for the entire graph. Would you be able to write a single equation for the entire graph? Tell me, guys. Would you be able to write a single equation?
No.
No, right? So, you know, that is when I split these graph into two different graphs. You see, what is the equation for this one? What is the equation for that one?
Y equals to X.
Yep. So I can say this is my equation. You see, let's say this function starts at -2. Till 2, I have that. So I will write -2 less than or equal to x is less than or equal to 2. Till then, my function is defined by a line. But after that, let's say till 10, the function is defined. I have a stop here. Then I'll say, hey, 2 less than or equal to x is less than or equal to 10. Because see, here already if it is equal to 2, I have covered. But after that, after 2, what happens? Well, how is my function defined? How is my function defined? It's a straight line. So
Equals to
let's say it's 3. Equals
Y
3.
equals to 3.
Yeah, so f of x, see now what did you do? Basically, you wrote f of x equal to x for some interval. Then you also said it's equal to 3 for something else. You are mentioning the interval here, right? See now, this is a piecewise function. Why it is called a piecewise function? There are two pieces and two equations that define the function in different intervals. So it's called a piecewise function. Make sense? Make sense? Now, it's just meaning more than algebra 2 or see, you know the concept of, I'm not going to do this now. This is a challenging question. I clearly put it out on the board. You're going to solve this by yourself. No, now you know absolute values, right? Very well know how to solve this. You know, state the breakpoints, give a correct piecewise form. So basically, this absolute value function can be modified. I mean, you know how to solve it. By equating it to 0, you know how to solve it, you know how to graph it, right? Now you can state the breakpoints. Breakpoints means where it changes, from decreasing to increasing, increasing to decreasing. Those are the breakpoints. Give a correct piecewise form. Define this, change this absolute value symbol, change this absolute value function or the equation into different functions. You can write 2, 3 functions between different intervals. Does that make sense? I didn't, meaning you only know, I have only taught you the concept of absolute value functions. But then I've also said about what are piecewise functions. Would you be able to change it? That is the most difficult question in the test. Make sense? I'm going to let you do this. Think about graphing. Think about solving this. Graph and see, then split it into functions and write the piecewise form. Make sense? Does that make sense or not, guys?
Yeah, it does.
Yeah. So please try by yourself. Okay. Only when you figure out, you'll be amazed. Put it down. You know how to solve this. When there are two absolute values, right? You know how to solve it clearly by equating it to 0. Like once you'll do this. This is the given one, right? Equal to 0. Suppose if you do, this will be equal to this. So now you know how to solve this x minus 1 equal to x minus 2, or you'll say minus of x minus 1 equal to x minus 2. You'll solve this, you'll get the breakpoints. But after this, try to graph it, put it into a table and try to graph it, figure out things. When you figure out some positive and negative values, you will know that you will get some graphs like this. Split that. However you want to split, you split it. There will be one line equation, another line equation, or a constant function. You have learnt about the basic functions, parent functions. With that, you know how to write the equation of this interval, write the equation of this interval. Use that, split your graph into different intervals and different equations. Give me the piecewise function. Any questions?
What's piecewise form though? Is it like
Piecewise form is, see, I told you, right? Cutting the, let's say I have a graph like this. This one can be an absolute value function. So let's say this interval is from -2 to 2. This one is to infinity. So this piecewise, you can call this as a piecewise function. This piecewise function can be defined from -2 less than or equal to x is less than or equal to 2. As an app, this function will be an absolute value function. You have to find the equation. Okay. This one is a constant function. So what you'll do, you'll say, let's say this was 3 on the y-axis. The same function becomes 3 after the interval 2 to infinity. Make sense?
yeah, but like when it asks for piecewise form, what would we put for this question?
You will put these functions in the intervals. Make
So like
sense?
just the intervals, right?
Yeah. No,
Alright.
not just the intervals. You have to write the function definitions on these intervals too.
Oh, alright.
You see what I mean? See this function now. This function now, let's say the intercepts are at -1 and 1. What will be the equation for this one? Let's say this is -2. What will be the equation for this one?
The equation for that one, for the second one is just y equals 3, but for the first one it's
One is y equal to 3, I wrote down. But for the
yeah,
first absolute value will be
y equals root x minus 2. I mean absolute value of x minus 2 with like the 2 x,
absolute value of x -2. Good job. So h minus k, you did it, right?
Alright, then.
So that's what. So you have to write out two functions and their intervals. That is the piecewise form.
Wait,
Make sense?
Aditi, I'm a little bit slightly confused. Can you go over the absolute value of x minus 2 one more time?
Because this is an absolute value function, right? What is h comma k? The vertex, right? Vertex is 0 comma -2. So the general format of an absolute value function is this, right? So here substitute h and k. A is 1, x minus 0, minus 2. This becomes absolute value of x minus 2. That is your function in that interval. Make sense?
Yeah.
So you have to remember this general format of an absolute value function. Can I move on, guys?
I have a question.
Yes, please.
What makes the equation like a breakaway? Why is it like not like a normal equation? Absolute value equation.
Sorry, I didn't get your question, Sricharan. What was that?
Like, why is it a breakaway equation and not like a normal equation?
Ah, okay. You can't write a single function equation that describes the entire thing, right?
Yeah, but like on the x plus 1 absolute value minus x minus 2, what like makes that a breakaway? How do you like recognize that it is?
This one, you can write it as an absolute value function, right? This is an absolute value function, right? You know how to write equations, right?
Yes.
This one is a constant function. So you will have to split it into two, right?
Yes.
Did I answer your question?
And I just don't know like why is it like the challenging question? Why is that one a breakaway? Like, which like part of it is like the constant?
I didn't get your question. What are you asking, Sricharan?
Like,
Breakpoint, see, till this one, you're able to define it using one function equation. Then the next function equation, there is a breakpoint here. You see?
yeah, but like, never mind.
Tell me, Sricharan. I want to clarify your question. Go ahead.
Like in the equation, where's the constant?
Oh, though f of x equal to 3.
In like the challenging question one.
I don't want to say that. You have to find that.
Okay.
You have to find it by solving that, by graphing that.
Oh, okay.
You got it? Once you graph it, you'll know everything.
Okay.
Take your time after the class. Okay. Yeah, I'm going to move on to quadratics, guys. I'm going to give that to you as homework. Is that okay, Srinita?
Yeah.
Yeah, I'm going to give it to you as homework, guys.
Wait, Miss Priya, it's not due directly after class, right?
No, ma, because see, some of you are not there and you're going to miss the test. It doesn't make any sense for me to skip those kids, right?
Okay.
So it is very meaningful so that everybody takes the test. Right, ma? That's why. Now, let's go ahead to quadratic functions. Last week we didn't do quadratic functions, right? Ananji, what are you doing in school?
School still hasn't started.
Oh, wow. Okay, that's good. So let's move on. So quadratic function is given by a times, how do you write it? X
X
minus
squared.
x
Oh.
minus whole square plus k. If you want to include horizontal compression or stretch, I will write it like this. Make sense? Please, this is your Bible. Just like an absolute value equation where you wrote a 1 by b x minus h plus k. Like this, you wrote your absolute value equation, right? Same thing for a quadratic function. This is going to be your general format. Any questions there? A indicates vertical stretch or compression. B indicates vertical stretch or compression. For B, since it is horizontal, you will always come reciprocal it and then say the factor. Got it? Now, H is the movement to the left or right. K is the movement up or down. Any questions here? Any questions here? I'm assuming everybody is with me. Navneet, are you with me?
Wait. If K is the movement of up and down, so H is the movement of left and right, right?
Correct, ma.
And
Now,
A is the stretch. And A is the stretch.
correct, ma. A is a vertical stretch or compression. If that A is a fraction value, is a proper fraction value, then it is a vertical compression. If it is 2, 3, like that, greater than 1, it's a stretch. But if it is negative, that also is a reflection on the x-axis. Here, if it is negative, it's a reflection on the y-axis. We
Also, what is this? What is this equation solve for? Is this what is the formula solve for?
a formula doesn't solve anything, but for transformation, it is very helpful.
Wait, auntie.
Yeah.
So if per se like a vertical stretch, it was a whole number, would we multiply the x by the reciprocal of that because it's a stretch?
Uh,
Or wait,
no, that, see, what you're asking can't be comprehended in a single sentence, right? Okay, let's go ahead and give examples. Let's go ahead with examples, guys. F of x equal to 2 times x square. What is this, Aryan?
that's a vertical stretch.
What is the vertex of this graph? This is, see, vertically, when you consider, you directly use this. You don't reciprocal it. 2 is your factor. When you multiply something by 2, automatically it is a stretch. So vertical stretch by 2. What is the vertex of this function? What is h and what is k?
The vertex would be 0, 0. Yeah, the
0,
origin.
comma 0, h, comma k, 0, comma 0. So that is your vertex. Any questions there?
Okay, no.
How about this? F of x is equal to 1 by 3x square. What type of a transformation is this?
Vertical compression.
Vertical compression. Why? Because 1 by
It's
3 is your factor. That factor is less than 1, so it has to be compression and it is applied to your y coordinate. So it is a vertical compression by 1 by 3. Make sense?
yeah,
I have
auntie,
another
I
question.
understand that, but I was just asking like what effect does it have on x? Like would I like multiply 3 like
Hold
to
on. Hold on.
get the full?
It's vertical. Vertical means it only affects your y coordinate. In this case,
Okay.
multiply y
Okay.
coordinate by 2. In this case, you will multiply y coordinate by 1 by 3.
Okay, got it, auntie.
Now, Ananjay, tell me.
Also, in what context would you use any of these equations? Like, if I want to find like the vertical stretch, how would those equations help?
So here, what is the multiplied number? See here. Okay. To match up with this, right? 2x squared. How are you going to match up with this? 2x squared. Now, when you think about it, put this 2x squared in my standard form. This is my standard form, right? 2 times 1 by 1, x minus 0, the whole square plus 0. Did you get it, Ananjay?
Oh, all right. So I can just substitute in and find the thing, right?
Exactly. Yeah. You see
All
what
right.
happened? H is 0,
Yeah.
K is 0, the stretch is 2. Make sense?
All right. Thanks.
We call A is for vertical stretch or compression. Negative value of A indicates a reflection on the x-axis. Negative value of B indicate a reflection on the y-axis. And B factor is always reciprocal because it's at the horizontal axis and it is 1 by B. See that? So the horizontal stretch or compression factor is always the reciprocal of B. Make sense?
Miss Priya,
Yeah.
I just have one question. Why do we need the 1 over B?
See, that's what A is vertical stretch or compression.
Mm-hmm.
He talks about horizontal stretch or compression, which
Oh,
I'll give you examples of. Okay.
so it's like the same thing, but like just
It is like the same. Yeah. See, I'll explain. I'll explain that. Now, f of x equal to, how about this? See now, the squaring takes place after the multiplication with x. The original, previously we did this one. See, we did squaring and then multiplied by 2. We did squaring and then multiplied with 1 by 3. So this was for our y. That is why this is applied to the y coordinate. So it was vertical stretch or compression. Here, the x coordinate is changing. X coordinate is being multiplied by numbers. Do you see?
yeah.
When you compare this with our standard equation, you tell me a times 1 by b x minus h the whole square plus k. What is the vertex of this?
1 so 1/3.
Vertex. Vertex is h comma k. Vertex means the bottom part or the top part. That is the vertex, right? What is that Hishkamake? Now, now my
0, 0.
0, 0. Good job. So I can write the same equation as I cannot write it outside because my y coordinate is not multiplied this time. See, it is inside the parenthesis. So
Mhm.
A is 1. But the problem here is if this was 1 by 3, what is my B value? 1 by
3. 3.
exactly. Yeah. 3 is my B. Correct. So if 3 is my B, you see, you always reciprocal. If some number is multiplied inside the parenthesis, you always reciprocal. That's why I'm saying. That is why if B is 3, what does it mean? It is a horizontal?
Ref
No. Horizontal stretch or
stretch.
stretch. So, but see what number you multiply inside is 1 by 3. So don't forget to take the reciprocal and see the factor.
Okay.
3.
I understand.
It is a horizontal stretch by 3. So here what happens is your x coordinate is being multiplied by 3.
Mm-hmm.
Coordinate, it's not 1 by 3. Horizontal alone is very deceptive.
Okay.
Horizontal alone, you have to take the reciprocal. Then check whether it is greater than 1 or less than 1. Then say based on that it is horizontal compression or a stretch.
Mm-hmm.
Okay, by that factor only you are going to multiply your x coordinate. Make sense?
Yeah.
Aryan, are you with me?
Yeah, auntie.
Okay. So now let's suppose I have this equation. What is this, guys? I'm giving you this equation. F of x equal to minus 1 by 3 x the whole square. What is the transformation? Anybody please volunteer, guys. Make mistakes.
Reflection over the y-axis.
Reflection on y-axis. Then
Then it's
And
reflection on the
uh,
y-axis affects which coordinate?
the x.
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 It affects the x coordinate. Whenever you the x coordinate will get multiplied by a negative 1. Good job.
Yeah.
Then
And then a vertical stretch by 3.
vertical. This is
Or sorry, horizontal.
horizontal stretch by 3, the reciprocal factor. Good. So what happens? It affects which coordinate?
The
Y.
x.
X horizontal, right?
Keep
No,
messing
no,
up.
you are right. You are right, Aryan. You said it right, but somebody else said it wrong. Horizontal stretch by 3 affects your x coordinate. Horizontally, you're stretching it. Your x coordinate changes. Then that's it, right? Good, guys. How about this? You're learning a lot very quickly. Let's see. How about this? Let's see. Okay, our original parent graph is this, right? Think about it like this. Our original parent graph is this, right?
It's
Uh,
reflected over the y-axis.
reflected over the y.
X-axis.
Oh, x-axis, yeah.
Reflection x-axis. Let's see. So the graph became this. Let's see one by one what happens to the graph.
Vertical
And
stretch by
horizontal stretch by 4.
Vertical it's outside the parenthesis.
Oh, yeah.
It takes time. It takes time. Vertical stretch by 4 means, see, vertically you're stretching it. You're holding the bottom of the U and pulling it up. So it becomes thinner. Makes sense? Vertical stretch by 4. Makes sense? It becomes steeper.
Right 3.
And then what? You move it.
3 to the right.
This is right 3, correct. So what happens? The bottom of the U comes 3 to the right, but thinned B. Okay, and after that?
Up 2.
Up 2. So what happens to the graph? It becomes like this. So my final graph, I'm going to draw it in what color? Black color. My final graph, I'm going to draw it in green color. My final graph will look like this. Make sense, guys? But you know what? I'm going to show you exactly what is going to happen. This is just a theory, meaning theoretically bird's eye view from a very big eye view, we are saying, hey, this graph. So my final graph should look like something like this. That's what you're saying, right? Is it really true? Let's compare. Is that really true? I don't know. What was that, guys? What was the equation? Okay, this I gave it from my brain. Let's see. F of x. This was the equation, right? Let's see what is it all about. I'll tell you how to do this. Follow. See, you can have different perceptions of understanding. Meaning, see, school teaches you. Yes, school does teach you in a way. But then, if you understand the basic concept of transformation, right? However they give, you will be able to answer whatever questions they ask. So let's see this one. F of x equal to this one, right? You know, you all told me this is a vertical. I'm sorry. What is it? What did you say?
Stretch.
Reflection.
On y-axis, reflection on x-axis, right? So it affects the y coordinate. And then you said vertical stretch by 4. It affects the y coordinate again. Then it is right 3. That affects x coordinate up to, it affects the y coordinate. We know that, right? Please write it down. Clearly, anytime, please write out the verbal description very nicely. After that, I want you to graph it, to be able to graph it. Without any mistakes, you should be able to graph it. So you know what I do?
Yes.
I go ahead and draw a table. First, I draw parent function. Then I draw transform function. Please draw both, meaning don't feel lazy, guys. This is quite important to, because the same thing applies to all the 17 functions we are going to learn. There is no change at all. X, Y. Now, in the parent function, you know a parent function, right? What is a parent function for this one? This is our parent function, quadratic equation. So let's say -5, -3, maybe -1, 0, 2, 3. These are the points I'm going to consider. I would consider 1 and 2, okay? Because these three are reference points. For a quadratic function, these three are reference points. -1, 1, 0, 0, 1, 1. Those three are reference points. Always we want to know where did those points go in a transform function. Any questions? So when I graph it, -1, 1, this one, 2, 4, 0, 0. That is my parent function. Any question on that? Now, from a bird's eye view, we have designed our graph like this. You're going to see what is going to happen. What happened here? How did my x change? Who can tell me? How did my x coordinate change?
Your x coordinate went right 3, so you would add 3.
Correct. Write that down. But for y, there's a lot of changes. What should I do with my y?
First thing you do with y is you multiply -1.
Good. So it becomes -y. Then what is it?
Then vertical stretch by 4, you would multiply by 4.
Yeah, -4y. I already know till -4y. But what happens here? Up 3 is what?
Add
And
2.
then
Add
plus
2.
2.
You all got it. Now it becomes very easy for me. You don't have to sit and slog. Oh my God, where did it go? Where did it go? I'm just going to add 3 to this. 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 This is difficult, guys. -4 times 25 is -100 plus 2, 102. -36 plus 2 is -34. -4 plus 2 is -2. Please let me know if you didn't get it.
Wait, Miss Priya, would the first one be 98?
Did I make a mistake? Yes, sorry. Got it? Yeah, I think
Mhm.
the rest of it is right. Then -16 plus 2 -14, correct? See, automatically, if you have this understanding, whoever makes the mistake, we can help out each other. What big deal, right? This is the concept behind this. Got it now? So let's plot it and see.
Wouldn't it be -98?
Did I make a mistake again? Yes. Sorry. Thank you. Yeah, that's right. Good job. Thank you. Thank you. Who was that? Arush. Thank you, Arush. Shall we go ahead? -2, -98. Somewhere down here. Okay. 0, -34. Somewhere down here. 2, -2. Somewhere here. -2, right? And then 3, 2. 3 comma 2. And then what happens? See, it's not drawn to scale. 4 comma minus 2 again. And then 5 comma minus 14, somewhere here. Do you see, guys? I'm sorry. See, it's not drawn to scale, but I think it's right. You see, guys? Are we getting something like this? It's not drawn to scale, I accept. But do you see how the graphing works? So always follow the verbal description, follow this table, do the graph. When somebody comes and asks you, right, hey, please tell me minus 1 comma 1 in my parent function, what happens to that point in this transform function? What do? Write out your verbal description. See what affects the y, what affects the x coordinate. Now this one, right, you know what is affecting. So for the x coordinate, pick only this. Add 3 and tell them. For the y coordinate, multiply by minus 4 and add 2 and tell them. You got it? This is the same for every function we are going to cover. There is no change at all. Okay, for absolute value, it's the same. You're going to write the verbal description, write the parent function, transform function, writing this is the key. If you get this right, everything is right. You will get this right only if you have this right. You will get the verbal description right only when you understand what are these transformations. Srinita, did you get it, ma?
Yeah, I got it.
Okay, Pranav, did you get it, Aryan?
Yeah.
Yeah.
Okay. Yes, ma, I'm here. I'm listening. Adira, did you get it?
Yeah.
Okay. So, Sahana, did you understand? Ananjay, did you get it?
I actually have a question. Where does
Yeah.
the negative 4y plus 2 come from?
Ah, that's what. Good question. Where does it come from? Let's find out where does it come from.
And the y's.
Yes, and what is it?
And the y, so like the second and fourth columns.
This is the parent function, Amma.
Mm-hmm.
Parent function is y equal to x square function. X, you can put any 3 negative values, 2 positive values, and a 0. Y equal to x square, right? So square it and write it down here. Square it and write it down here. That's the parent function, right? You didn't understand this one?
Yeah.
Okay, now you have x and y coordinate in your parent function. What happened to your x coordinate? Only x coordinate got affected by the movement by 3 to the right, correct?
Mm-hmm.
So you added your parent x coordinate by 3 and put it in here. You got it?
Okay.
What happened to your parent y? Parent y, what and all changes it underwent? It was multiplied by a negative 1. It was multiplied by a 4. Do you see? It was multiplied by
Okay.
a 4. So it was multiplied by minus 4 due to these two.
And then you add 2, right?
Exactly. So the key for you is to write these two. Writing these two is the biggest challenge I've ever seen in Algebra 2 kids.
Mm-hmm.
Does that make sense?
Yeah. All right. Thanks.
Any other questions?
Not really. I get it.
Okay, good. I'm glad. Sri Charan, did you get it?
Yes.
Chetan, are you able to follow a little bit, Chetan? Chetan, you're muted, Amma. You might need. So, yeah, yeah. What is it, Chetan?
It takes me a while to unmute sometimes. I'm understanding a little bit.
A little bit, okay. I see. So now, when you come to the properties of this function, right? The same graph we'll use, guys. The concept is the same. If you understand any one thing you understand, then you develop on it. Okay. For my parent function, when you think about it, let's talk about the end behavior of the parent function. What is the end behavior of the parent function? What is the end behavior of the parent function? I'll write end behavior as As x tends to minus infinity, what happens to y? As x goes to minus infinity, what happens to my graph?
Infinity.
Y goes to infinity, or f of x goes to infinity. As x goes to infinity, what happens?
Y goes to infinity.
Y goes to infinity. This is called the end behavior of the graph. What is the domain and range of the parent graph?
The domain is all real numbers. And the range is
You are all in algebra 2. I don't want this all real numbers like algebra 1 kids. So I want it in inequality notation.
okay. Minus infinity is less than x is less than infinity.
Nice. What is the range?
Range is 0 is less than equal to y is less than infinity.
Good job. Any questions on that?
No.
What are the x-intercepts, y-intercepts? What are the x-intercepts, y-intercepts?
The
Zero.
The x-intercept is the origin 0, 0.
Mm-hmm.
Is it
And
is the y-intercept
same for the
-4
y-intercept.
or -34?
Amma, please wait. I'm talking only about the parent function. I'm talking
Wouldn't
only
it also
parent
be the
function.
origin?
0, 0, yes. And then what is the increasing, decreasing interval? What is the increasing interval for the parent function?
0 is less than x is less than positive infinity.
Aha! Increasing interval, you always write only starting, ending, and then do a parenthesis. No inequality notations. What is the decreasing interval? Go ahead, Ananjay. You can correct now. Decrease.
Negative infinity is 0.
Yeah, the negative infinity is your lowest point. That from there it comes down till 0. That's a decrease. Any questions now? Sricharan, are you with me? Srinitha, are you with me?
Yes.
Okay, now we are discussing quadratic function. Now the transformed function looks like an inverted U. For Chetan, I am telling it is an inverted U where the bottom of the graph, I don't know, where is the bottom of the graph? Looks like 2 comma minus 2 is the bottom of the graph.
What's up? I keep making the same mistake on the same coding problem,
Listen,
and I did the attempt twice. Can I
One second,
wait for
guys.
you and do it the
Yeah,
third time?
please. Now, let's same things I'm going to talk about in the transformed function. What is the domain and range? Who can tell me? Ma, please switch people. People you switch, meaning that way you make mistakes and learn. What is the domain? Feel free.
Negative infinity
Mhm.
is less than x is less than infinity.
That remains the same. Good job. Range. Range, what happened, Amma?
The range would be 2 or no. Negative infinity is less than y is less than equal to 2.
Sorry, Arush. Repeat. I was not attentive. Go ahead.
Negative infinity is less than y is
Uh-huh.
less than equal to 2.
Good job. So negative infinity to 2. Why 2? See, our vertex is 3 comma minus 2. Do you see that, guys? 3 comma minus 2. 3 comma plus 2, right? The vertex is, let me write down the vertex of the transform function. It's 3 comma 2. So he says the domain goes till 2. 2 is the maximum value of this function. Okay, now what and all we need to discuss? End behavior. Let's discuss end behavior. Who wants to say this time? Can I pick Aryan? As x tends to minus infinity, y tends to? As x tends to minus infinity, I'll help you, Aryan. Y
Yeah.
tends
As x goes to minus infinity, y goes to
see the graph. Where does it go?
in infinite.
Infinity is here.
Yeah,
Minus infinity is here. Y goes to?
negative infinity.
Correct. As x goes to plus infinity, what happens? Y goes to?
Positive infinity.
Really?
Or wait, no.
See the graph. Where does it go? This is x going to plus infinity. Where does the graph go? I'll help you, Aryan. See, x is going to positive infinity. When you go to the rightmost side, what will
Yeah.
be my graph value? Y value of the graph?
Y goes to
Negative infinity.
negative.
Good job.
Yeah.
That's the end behavior. Now,
Okay.
what is it? Yeah? You want to say increasing interval?
I have to go right now. Sorry.
You can, Sricharan. You go ahead. What is increasing interval?
The increasing interval would be neg.
Which
I
is
think
the increasing interval? First tell me. Okay, you want help?
yes, please.
You are being put under the bus. I'll ask somebody now. Adira, you want to say? I really don't mean to put you on the spot. So anybody can share, right? You can help each of you. What is the increasing interval? Navneet, you're keeping quiet. Can you help us out?
Sure.
Please.
I think the increasing interval is negative infinity
This
to
is your increasing interval, right? It goes up till this point. So what is the increasing interval?
2.
Yeah, you always say the x values. You
Oh,
always
3.
say the 3 minus infinity to 3 is your increasing interval. What is a decreasing interval?
3 to
3 to positive.
Correct. You got it, guys? Yeah, beat any graph. Any graph, any transformation, any property, you should be too good if you attend this class. That's the intent. Ask questions if you have. What other questions you have? Okay, how about this? Parent graph is odd or even? Every time I'll keep asking for every function when we go through. Is it odd or even?
even,
Why do you say so?
because it reflects around the y-axis.
Odd or even? Yes. Odd means symmetric about the origin. I'll keep telling, even if you forget, I'll keep telling so that you remember. Even means symmetric about the y-axis. Neither means it's not symmetric about the origin or about y-axis. Any questions? This is from the graph. You got it? Now, how about this? This graph. Oh, we had an equation, right? Let's go back, please. Sorry. We'll see about the symmetry. Algebraically, let's see what is the symmetricity. I'm going to go back. This is our equation, right? The same function we'll think of for everything. I'm going to delete all this, okay? But the same function, let's see whether you know the graph of that. We drew the graph already, right? You told the verbal description. You wrote the table for the parent function, transform function. Then we drew the graph. You have the graph. You know whether it is symmetric or not. Can you tell me whether the transformed graph is odd or even? Transformed graph is odd or even?
Neither.
Neither. Good job. Because it's not symmetric about the origin, it's not symmetric about the y-axis. But algebraically, how are you going to verify that? Algebraically, you'll have to verify that. How? If f of x is equal to f of minus x, meaning instead of this x, you substitute minus x. Then if you get the same f of x value, then it is even. If f of x equal to negated value of the original, or okay, let me put it this way. I should have put it this way. Hold on. I don't want to confuse. So, sorry guys. Okay, so when do you say the even function? When f of minus x is the same as f of x, meaning when you, instead of f of x, you substitute minus x and c, you get the same function. Then it is even. But if f of minus x, you get the negated value of the original f of x, then it is odd. How do you verify this? Let's find out. F of x is given here, right? I'm going to put f of minus x. So wherever I see the x, I'll put a minus x. Yeah, I did. Let me put it out and see. Now, what happens to this function? When you expand it, right? This function, when I expand it, what happens? Minus 4 x square plus 9 minus 6x plus 2. This function becomes minus 4x square plus 30. Oh my God. Minus 36 plus 24x plus 2. I can write the same function as minus 4x square plus 24x minus 34. This is my f of x. Any questions on this? This function, when I expand it, what happens here? Minus 4, the negation, take it out. If I take it out, it becomes x minus x plus 3, right? Or let me do this. Minus x is a, minus 3 is b. It is a plus b the whole square. So x square plus 9 minus 3 square is 9. Now, it is like plus 2ab. Everything will result in positive, right? So 6x, right? Yep, and then a plus 2. Now what happens? Minus 4x square minus 36. Then what else? Minus 24x plus 2. Now minus 4x square minus 24x minus 34. What is the relationship between f of x and f of minus x? There is no proper relation. Do you see? It is not getting negated entirely. Only one term of it is getting negated. So I can't say f of minus x is equal to directly f of x. I cannot as well say f of minus x is equal to the negated value of f of. That means every term should be negated. It's not. So it's neither even nor odd. So it's neither. Any questions, guys? Clear, huh? Ananjay, did you follow? Aryan.
Yeah, auntie, I followed.
Yeah, I did.
So even odd, you should be able to tell it just like that when you're given a function, both algebraically and graphically. Got it? Now let's see. Did we discuss inverse functions, guys? Did we ever discuss inverse functions? Did we ever discuss inverse functions? Yes, no, I forgot. 3 answers are there.
I don't think we did, auntie.
Yeah, I don't
I'm
think
not
so.
sure.
You all really forgot. Ananjay, do you remember? Oh, Ananjay was new. No, you were new. You did not attend those classes.
I don't think we did it.
Ah, Arush, you were in India. Can I show you? And Aryan, you know what? That is the homework I followed up with you.
Oh yeah.
Remember? Wait, let me go back. Yukti, do you remember us discussing?
Yeah, I feel
Yeah.
like you did like a touch base on it, but it wasn't like a full explanation.
Yeah. I'll go. No, it was a detailed 2 class on that. I'll show you. Wait.
Miss Priya,
Oh, guys, forgot. It's
are
okay.
we not doing the test in class anymore?
No, ma, that's what I said, Adira. I'm going to give it to you as homework, right?
Okay.
Okay. Now, guys, remember, this was the class that we discussed. Ananjay was not here, I know. So here, let's go over that. Algebra 2. Here we go. Classwork. Go back. What are these? Oh, we didn't go over them. Yeah, see here. Function composition and inverses. Remember, you did not understand the 15 questions. Aryan. Do you
Yeah,
remember?
auntie, I remember.
Yeah, so we did composition and inverses. This was the first week we covered. There were some notes, and then there was also a detailed inverses and composition homework given. Okay.
No, Miss Priya, I feel like this is a thing that you did in summer.
Yeah, summer, yes, absolutely, yes. Agree.
Yeah, okay.
Agree. Absolutely in summer, not now. Okay, now I will review that, guys. Absolutely no problem, because some of you were in there as well, right? So let me go back. Let me share my screen. What was our equation? Let's see. This one, I'll give you an insight and then you can keep going. F of x equal to minus 4 x minus 3 the whole square plus 2. This was our equation, right? Okay. How do you find the inverse of a function? This is a review, guys. Please remember. The thing is, why do I grind during summer all this? Because this is applying to every function we learn and it's the same logic. There is no difference. How do you apply the inverse? First, I rewrite the function like this. Right? And then, you know what I do? The first step to find the inverse is switch y and x. X will be equal to minus 4, y minus 3 the whole square plus 2. Any questions here? Then the next step is solve for y. That is your inverse function. You solve for y, that is your inverse function. X minus 2 will be minus 4 times y minus 3 the whole square. Divide by minus 4, divide by minus 4, it becomes x minus 2 by minus 4 will be y minus 3 the whole square. I can write that down as 2 minus x by 4 will be equal to y minus 3 the whole square. Take square root, 2 minus x. Inside the square root, divide by 2 will be equal to y minus 3. Now, square root of 2 minus x by 2 plus 3 will be equal to y. This y is your inverse function, f inverse of x. Make sense, guys? Do you see how to find the inverse? Arush, do you remember? No, not yet still.
I don't think I was at class. I don't think I was at the class, but I remember from last year, like we did in school.
No problem at all. Okay. Algebra only you might not have done, right, Arush?
I don't know. I remember doing it in school some year.
Forget it. Okay. So how to find out the inverse function? Inverse function is not the reciprocal function. 1 by f of x is not equal to f inverse of x. Inverse function is very different. You have a function like this. Graphically, when you have a function like this, how to find out the inverse? Draw the line y equal to x. Split each graph into pieces. Reflect it on that line. This is your reflected function. Then the second piece is what? Second piece is this. Reflected. What happens? This one. And then the last piece. This is your function, right? Reflected on that line. So now my reflected function is this. You see? Graphically, be it any graph given, you are going to reflect it on the line y equal to x to get your in. If this is your f of x, this reflected graph is your f inverse of x. Got it? Now, algebraically, how do you find the inverse function? You are going to switch y and x, then solve for y. Whatever y you get is your inverse function. That inverse function graphically will represent the graph what you get by reflecting your original function on the line y equal to x. Coming to inverse function, let me review this. Inverse function is nothing but a reflected version of the original graph on the line y equal to x graphically. If you can't reflect it, split the graph into part by part, reflect it on the line y equal to x. Algebraically, to find the inverse, write y equal to x format of the functions, which y and x solve for y. Any questions? Any questions? Okay, guys, you know what I'm going to do? I'm going to give you problems from the book, but additionally for inverses alone, I'm going to give you a detailed review for this week, because looks like several of you have forgotten. So we'll review just the inverse part and then do some quadratic functions. Okay, any questions? Any questions for me?
No, auntie.
Okay, I'll stop here. Bye, guys. See you all next week. If you have questions, you can stay.
Thank you, Miss Priya.
Bye,
Yes.
Miss Priya.
Bye, Miss
Thank
Priya.
you. Bye.
Priya auntie.
Yes, ma.
So do we have to finish like the test right now? Because I might also have to go somewhere.
Not. You can do
Like
it.
the absolute value test.
You can do it later, ma.
Okay. I'll
Next-
make sure to finish my homework this week and I'll do it on time, auntie.
So nice of you.
Okay.
Anything
Bye,
else?
auntie. Have a good day.
Bye, bye. Don't try. If it comes out badly, it comes out badly.
It's still eatable.
It is, but
Maybe we'll add a little.
அம்மா
Ah.
இந்த பீச்சை ஏமா ஃப்ரிட்ஜ்லயே வைக்கல ஏண்டா ஒழுங்காவே இல்லையே they're not nice இருக்கிற பீச் தான் அது பண்ணுங்க நான் எங்க போய் வைக்கிறேன் இல்லம்மா but like they'll go bad faster அதுக்கு என்ன பண்றது அப்படின்னா நீங்க வச்சுட்டு போகணும்ல இல்ல சொல்லவான்னு சொல்லணும் இல்ல I don't need them a certain way okay well, I'm just saying in general we're not going to finish this many beaches before they go bad we leave them out yeah we can put it outside now put it in the fridge yeah did I put it yeah sure. Is this a yellow beach here? Other yellow beach.
I think all of those that are
going Huh? The yellow beach and yellow beach. You think it's a white beach? Yeah, because first of it another this is other one. Yes, yellow. What's up? That's probably enough beaches. Huh? உள்ள வச்சிருந்தா நான் வைக்கிறேன் I know, but you gotta go faster. Give me this. Peel that. Keep peeling.
you can have.
I'm feeling the melon of it. I'm feeling that.
No, my teacher said.
Okay, be careful. Don't put the peels. Put the peels somewhere else. Put the peels on this plate. The book. Look that big. Put the peels on that. Let me see if I'm being from. You're not. If this doesn't. So either 75 to 80 minutes on long and look like this. Yeah. So you're gonna pick it up. Are you guys up on that consider sleeping upstairs tonight? Sure. நான் சொல்றேன் பாட்டு கேக்குறேன் ஏண்டா Just so we can fit. Yeah. Well, like, yeah.
Is it okay if
Yeah, that's fine.
can you look?
Yeah, that's fine. I absolutely large pieces of like fuzzy.
What? No. All of that.
This is a chunk, okay? So, I'm gonna start that again. Yeah, but the feeler, I don't know if it'll work very well on right ones. You could try.
I'll get to this one. Can you bring that plate here, please?
Speech speaking எப்ப முடியும்? அது இருக்கும். அது இருக்கும்டா. எப்ப வரைக்கும்? அது இன்னொரு 1 வாரம் 2 வாரம் நிச்சயமா இருக்கும்னு நினைக்கிறேன். இப்பதானேடா. It will take time. ஏன்? I'm scared. திருப்பி போகணுமா உனக்கு? No.